Hey folks, welcome back to another video. Today we're looking at question 604, design compressed string iterator. The way we'll be solving this problem is actually by figuring out what needs to be the next character within the next method itself instead of pre-computing it. So let's get started. The first thing that we need is a pointer that keeps a track of the current index. So let's initialize that to current index to be 0. And every single character has a counter associated with that. So let's initialize that to be 0. And the current character, let's just initialize that to space. What are the other things that we need? This particular string needs to be accessible in the next method. So let's initialize a variable and assign it within the public string iterator method. And the other thing we would need is also the length of the string. Okay, so once we have all of the variables that we need to access globally, let's have s to be set to compressed string and n to be set to the length of the compressed string. So we have the other two methods that we need to complete, next and has next. We will know that there is a next character if these two conditions, one of these two conditions are true. So the current index, if it is less than n, or if the counter is greater than 0. So, and the reason why we need to take both of these into consideration is because even if we reach the very last index, there is a possibility that the counter hasn't gone all the way to 0. So that's the reason why we need to go all the way till the end, and we need to use both of these conditions. And only when both of the conditions are false do we know it doesn't have next. So in this condition, if the index is less than n, or if the counter is greater than 0, we would return true. If not, we would return false. And for has next, first let's check if it does have next. If it has next, we will do some computation. If not, we would return just a space character, which is what's required. Returns a white space if you don't have anything. If it has next, there are two conditions within this method itself. If the counter is less than 0, oh actually if it is equal to 0, we need to figure out what the counter is and what the character is. If not, we just subtract the counter by 1 and we return the current character that has been assigned. So if the counter is equal to 0, the character is just pulled from the current index. So s dot character at current index plus plus, and we need to know how many times we actually need to go through it, right? Like, so what is the counter that comes after that? In the example that's given to us, we only have like single digits, but it could be more than one digit. That's the reason why we need to have another check here, where while the current index is less than 0, or sorry, is less than n, and if the character that we're looking at is a digit. And how do we check that? We use the built-in character method that we have, dot character dot is digit. As long as this is true, we need to keep updating the counter. So the counter would be equal to everything that we've seen previously. We multiply that by 10 and then add the particular character that we've seen so far. So that would be s.character add current index. Now let's increment that, but we need to subtract it from the character 0. And the reason why we need to do that is because of the ASCII values. When we extract these values, it's not going to give us 0 as an integer. It's going to give us 0 as a character, which has a different value because it's returning the ASCII value. There's a reason why we need to subtract it from 0 character. Sorry, yeah, 0 character, which is like a string value. If you look this up, you should be able to understand why. And just to make this case a little easier to understand, let's say it has A1, B 100, C 3, right? So for A, there's only a single digit, so we just need to care about the next character that comes after that. But as soon as we hit B, that needs to repeat itself 100 times. That's the reason why we need this while condition. Okay, let's try running this. I think that is all we need. Let's try running this to see if it works. Ooh, all right, okay. Okay, let's try that again. Okay, the first test case is okay. Everything else is okay as well. Okay, so let's talk about the space and the time complexity. For both of the methods has next and next. The space and the time complexity is of 1. Because we're not using any additional space, and the time, we could argue that the time complexity could be like of n, but the number of characters, oh actually, okay, the length would be less than 1,000, but the number of times a single character can be repeated is 10 to the power of n. So one could argue that it is limited because it's given in the constraints. So if it could be of 1 or O of n, but I would say it's of 1. But let me know what you think in the comments. All right. So if you have any questions that you want me to solve, let me know in the comments below. And don't forget to subscribe to the channel. It definitely keeps me motivated